Guys, this is section 3.1, lines and angles. So, beginning of a new chapter. We've got some definitions. That seems to be the case in geometry. We start a new chapter, we have lots of definitions. Parallel lines are coplanar lines. That means they're in the same plane, like the board that you see right here, that don't intersect. So, two lines in the same plane that don't intersect are referred to as parallel lines. So on your paper, if you draw two lines that never intersect, they are on the plane of your paper, and they are considered parallel. Skew lines are non-coplanar lines. That means they're not in the same plane, and that is the reason that they don't intersect. So two lines that are not in the same plane, like if you look in the room that you're in right now, look along maybe the floor and see the edge that goes along the floor, and then maybe one of the edges that goes along the ceiling. They're not going to intersect, but that's because they're not in the same plane. It doesn't necessarily mean they're parallel. So there is no one plane that would contain both of those lines. Parallel planes, if you look at the ceiling and the floor, you're looking at parallel planes. They're planes that don't intersect. So look at the ceiling and the floor, you've got parallel planes. A transversal is a line that intersects two or more coplanar lines. So here's a couple of coplanar lines here and here. The transversal will be in red, coming right through those. There's my transversal. So we have this picture in example one. This is a two-dimensional picture meant to look three-dimensional, so this will hopefully help us to understand some of these definitions. We've got parallel to AB, so we're looking for something that's parallel to AB and contains D. So parallel to AB and contains D. So parallel to AB and contains D would be the line CD. You can see it right over here. If I can get this to show up. Do not draw it right over here. We're looking for a line that's perpendicular to AB this time and contains D. So that would be, in this picture, line AD. I'll do that in a different color. How about green? Hits this in such a fashion that it makes a right angle right there. So AD is perpendicular to AB is perpendicular to AD. The next one, skew to AB and contains D. So this will be my attempt at drawing what I said earlier. So skew to AB and contains D. So we've got three different choices. Let me draw each of those. First in blue, we've got ED here. So that is skew to AB. Skew to AB and contains D. So it goes through D. It will never cross AB, but that's because it's not in the same plane. So that's why they don't ever cross. DH is another one. I'll do that in purple here. So DH is skew to AB. They will never cross because they're in different planes. And then finally, DG is another option here. DG comes right on through here. Those are skew. They will never cross because they are in different planes. Plane, we're looking for a plane with D and parallel to ABE. So a plane with D in it. I've got to erase this mess over here. And we want it parallel to ABE. So ABE is like the left side of the room here. It's over here. So we are going to find the plane parallel to that. That is DCH. That is over here on the right side of the room right here. So DCH is a plane with D in it that is parallel to ABE. Remember, for planes, we name them with three letters. All right, a couple postulates here. I'm going to draw you pictures of these two. We've got the parallel postulate. It says if there is a line and a point not on the line, so let me draw a picture of that. So if there is a line and a point not on the line, there is exactly one line through the point parallel to the given line. In other words, you can't draw that green line in any other way and still have it be parallel. There's one and only one parallel line through that blue point, parallel to the blue line. So, second one is a perpendicular postulate. If there is a line and a point not on the line, so if there is a line, let's do that in blue, and a point not on the line, we'll also do that in blue, there is exactly one line through the point perpendicular to the given line. There's one and only one green line right there, perpendicular to the point. So I would draw pictures for these so you have an idea of these two postulates. You don't have to remember the name of it if you could just describe it in words when it comes up. If there's one and only one line parallel to a given line through a given point, there's one and only one line perpendicular to a given line through a given point. All right, we have some angle relationships. This is our example of two lines cut by a transversal. Here are my two lines. There's one here, cut by a transversal. That's this guy right here. It creates some sets of angles that have special names you'll need to know. Eventually, we will have some postulates and theorems about these special angles when the lines are parallel. The first of the lines, first of the angle relationships you need to know are called corresponding angles. I'm going to list some corresponding angles. If you were to take this vertex right here, slide it down, overlay it on this vertex, the corresponding angles are the angles that are in the same position in at that new vertex. So for example, angles 1 and angles 5 are corresponding angles. Angles 3 and angle 7 are corresponding angles. Angles 2 and 6 are in the same position in the respective vertices, and angles 4 and angle 8 are corresponding angles. So those are corresponding angles. All right, they are in the same position. Alternate exterior angles, another type of angle pair you need to know. Let me erase all this. So alternate exterior angles, we're going to list some pairs of those. They are on alternate sides of the transversal, and they are outside of these two lines. So they're on alternate sides of the transversal, outside of those two lines. For example, we've got angle 1 and angle 8. Those are alternate exterior angles. Also, we have angles 2 and angles 7. They have an AKA here. They are as far away as they can be on these pictures, like 2 and 7, so we also call them the haters. That was a term a while back ago that was popular. So that's it. Alternate exterior angles, those are the two. Alternate sides of that red transversal, outside of the two lines that are cutting through there. All right, I'm going to move this down. Let's move this down so we can see it. All right. Alternate interior angles. So alternate interior angles are angles that are on alternate sides of the transversal, but in between the two lines here. So for example, I have angles 4 and 5, and I have angles 3 and angle 6. Those are alternate interior angles. 4 and 5, 3 and 6. Finally, this one has a couple different names. It depends which textbook you might be using, but these are called consecutive interior angles. They are also known as same side. In this textbook, they're actually called same side interior angles. Same idea, you should know both. So same side interior angles. They are on the same side of the transversal, and they are in between the two lines. So this picture would work for that as well. So same side of the transversal, in between the two lines, like 4 and 6. So angles 4 and angle 6 are same side interior angles. Also angles 3 and 5 are same side interior angles. All right. That's it for 3-1. Hope that helps.